The velocity of a sound wave traveling in air is 330 meters per second. If the period of the sound wave is 10 raised to the minus 3 seconds, the distance between a rarefaction and the adjacent compression is. In this question, the speed, the velocity is given as 330 meters per second. The period of the wave is 10 raised to the minus 3 seconds. The distance, we're looking for the distance between the rarefaction and adjacent compression, which we don't know. For a sound wave, distance between successive rarefaction, between two rarefaction is a wavelength. Likewise, the distance between two successive compression is also a wavelength. But the expression for the distance between a rarefaction and adjacent compression is half of a wavelength. Half of a wavelength. That's half of a wavelength. First and foremost, we need to find the wavelengths. From the wave equation, speed is frequency times wavelength. And also, this can also be expressed, since frequency is 1 over the period, it can also be expressed as the wavelength all over the period. Here we can say the wavelength is the frequency times the period. The wavelength is given, the speed is given as 230, and the period is 10 raised to the minus 3. If you multiply that using a calculator, that will give you 0.33 meters. I'll give it 0.33 meters. Then the distance between the rarefactors and adjacent compression, which is half of a wavelength, that's 0.33 divided by 2. That will give us 0.165 meters. This is the distance between the rarefaction and adjacent compression.